Hi friends, welcome back to the videos in which we will be solving the problems for the straight line motion 1, 2, 1, 2 and the questions from 6 onwards. Okay? So let's go back to the problem. Just a small reminder that if you are liking the videos, we would request you to like hit the like button and also try to subscribe on these videos so that if there are any new releases you'll be notified. Okay, so thanks everyone for appreciating and let us know if you have any feedback. Thank you. So let's look at this problem. Question number 6. The position of a particle varies with time as x is equal to, so x is given as x is equal to t square minus p t q plus m. Okay, and what is it asking? That the acceleration will be 0 at what time? Okay, so we basically need to find at what time will the acceleration be 0. Be 0. So if you've seen the previous video and the previous solutions what we given, in case we have been given expression like this, right, which is the expression for distance x and expressed in terms of time, which is t, and some constants. So how do we find velocity in such cases? We simply do the differential, right? So we do dx by dt is equal to, if we do a differential of the right side also, this becomes 2kt minus, if we do differential of this becomes 3pt square. Correct? So now this becomes the velocity, as you might be very well aware of, right? So how do you find the acceleration? Acceleration is a further differential of the velocity, which is dx d2x by dt2. So we have to differentiate this once again, right? So if I differentiate this once again, I will get 2k minus 6pt. Now, as per the problem, so it is asking that what time the acceleration will be 0. So if the acceleration has to, this is the acceleration as we said, right? And if this has to be 0, it means 6pt is equal to 2k. Correct? Means time t is equal to 2k by 6p. It means t is equal to k by 3p. Okay? So this is the time at which the acceleration will be 0, right? So this is the solution here. If you look at the answers provided to us, the answer. Okay. Now let's go to the next problem. In the next problem, it is said that there are three bodies were allowed to fall from rest, and they follow three different frictionless paths. Okay. Now, one important thing here to notice is that these are all frictionless paths, right? Please remember these frictionless paths. Now, from you might be knowing from conservation of energy, right? Conservation of energy. What happens is that, see, energy changes from one form to the other. So in this case, there are three objects which are made to fall from the top to the bottom. Correct. So imagine that there's a tower here, a very long tower. Okay, and some bodies are made to fall here. So at this high position, so these objects will have some potential energy, right? Potential energy. And as you must be knowing that when they fall to the bottom, they get converted to kinetic energy. Okay. So now, so when these bodies are falling from the top to the bottom, that means they are getting converted from potential energy to kinetic energy. Now at this high position, what is the potential energy? Potential energy, or PE, is equal to mgh, where m is the mass of the body and h is the height of the body at that particular instant. And what is the Ke, or the kinetic energy at which to which it will get converted? This is given by half m v square, right? So v is the final velocity which is obtained by the body, right? And m is the mass of the body. So if I convert these two, so it means m g h is equal to half m v square. Okay, so m gets cancelled. It means v square is equal to gh. Now, one thing important to note here is that this is independent of mass m. Okay, independent of mass m, right? So it means, what does it mean? So it means if a body is thrown from here, sorry, if the body is thrown from here, if two different bodies are thrown, okay, if the height is the same, if height is the same from the ground, and if they're frictionless, there is no friction on the way, then the velocity obtained is only dependent on the height, because g is the same, acceleration due to gravity is same, it only depending on the height. And if they're falling from the same height, regardless of their mass, so they will obtain the same velocity, correct? So if even if it is say 5 kg mass, if this body has 5 kg mass and this is 10 kg mass, it doesn't matter, right? So both of them will obtain the same velocity when it comes on the at the ground level, correct? It means all of them will have the same velocity, right? So the answer here will be 1 is to 1 is to 1. Okay, let's go to the next problem now. So it's given that a person goes to office and here, okay, he has an escalator in the office, right? So how does the escalator work here? So let me give you a basic thing. Imagine this is the ground floor of a building, right? And this is the, say, first floor of a building. First floor of the building, correct? Now, this escalator you must have seen in several offices, or you might have seen in airports, railway stations, etc., right? So these elevators are placed so that a person can board this and it can move upward automatically. Correct? So that is the function of the escalator, that without doing anything they can actually move up, right? But imagine if the escalator is not working, right? So this is called an escalator. Okay, but imagine if the escalator is not working, right? If it is working fine, then the person boards the escalator and it goes up to the next floor, next top floor. But if the escalator is not working, right? If escalator is not working, it's just working as a staircase, right? So a person has to walk up the escalator just like a staircase to reach the next top floor. Okay. So now let's assume that, so we are talking of two different things here, right? So imagine that there is speed at which of walking. Imagine this is equal to VW. Okay, so VW is equal to the distance from the ground floor to the top floor divided by the time taken for walking. Okay, in this case it is given that the time taken for walking is dA, right? So this is equal to S by dA. And when the escalator is moving from down to the top, so S speed of escalator So this is VE is equal to same distance divided by T of E. E is a escalator, okay? So in the question, this is given that this is a TB, okay? So this is S by TB. Now imagine both are working, right? Imagine the escalator is also moving as well as the person is also walking on this, right? So it means he gets an added benefit, right? He'll be able to move faster, correct? So if he's going up, then what happens is that the speed of the escalator and the speed at which he's walking both will be added, right? So what will be the speed at which he'll go then? He'll go at VW plus the V of escalator, right? Velocity of walking plus the velocity of escalator. So now let's come back to this. So what is joint velocity? Joint velocity or combined velocity, right, is equal to VW plus VE, right? This is equal to S by TA plus S by TB. So if you do the LCM, it becomes plus TB upon TA into TB. So this is the joint velocity or the combined velocity of the lift of the escalator and the person combined. So now let's look at if both are working, then how much time is taken? Time taken is equal to the distance which is S between the ground floor and the first floor, distance S divided by the speed, right, of speed of the joint velocity, correct? Because both are working now, which is VW plus VE, right? VW plus the VE, okay? So this is equal to S by, we have already found this out, TA TEP divided by TA into TP, correct? So this is equal to S into TA into TB with S into B. So S gets cancelled. So this is equal to TA into TB divided by TA plus TB. Okay. So this is the answer. This is the time taken when the person is walking as well as the escalator is moving, right? So this is the answer given to us. I hope this is clear to all of you, right? Now we go to the next problem. So a small block slides. So now let's visualize the problem, what is happening here. So imagine I have an incline here. Okay. Okay, I have an incline here. It's like this. This is alpha. Okay. This is alpha and this is G and this is the acceleration in this direction. Okay. This is G and this is this. Okay. So now if this is the acceleration in this direction, right? So we know that sine alpha is equal to G by A. Okay. Or it means A is equal to G by sine alpha. Okay, please remember this is a point. Now, what is the time? What is the distance traveled? Different traveled in n seconds. Now let's understand that in the problem it's given that it is starting from rest. Okay, so if it is starting from rest, it means initial velocity or the initial speed is equal to 0. This is u. Okay. So then what is the velocity or what is the formula for this? S is equal to, we all know this formula, ut plus r a t square. Okay. This is equal to, since this is 0, so we can remove this, the half into the acceleration into t square. So t square, I can replace this by n square. Okay. So this is a total distance traveled in n second. Now what are we seeing here? Okay. So imagine a body is falling from here. Okay. Now, okay. So now imagine that it keeps falling here like this, right? So in n minus 1 second, it might have reached here, correct? Might have reached in n minus 1 seconds. Okay. In n seconds, it would have reached here, this point, correct? In n plus 1 second, it would have reached here, right? Okay. Yeah. So in n plus 1 second, it reached here, right? So what we're trying to see is that the distance n second means this distance, right? This distance. Okay. This is equal to half into a into n square. Okay. Now, what is the distance in n plus 1 second? Similarly, is equal to half into a into n plus 1 whole square. Correct? So this will be the distance traveled in n plus 1, when n plus 1 is the time span given to us, right? And what will be the time? What will be the distance in n minus 1 second? This is equal to half a into n minus 1 whole square. Correct? So now let's calculate that how much is the distance in the n between n minus 1 to n second, right? That is this distance. So this is the it is basically the difference of this one and this one, correct? So this is s in n second minus s in n minus 1 second, correct? This is equal to half a n square minus n minus 1 square. Okay, so this is equal to half a n square minus n square minus 1 plus 2n, right? So this is equal to half a 2n minus 1. Okay, so this is the distance traveled in the nth second. Okay, similarly, the distance traveled in s of n plus 1th second. Okay, what is that? We are talking of the n plus 1th second, right? So it means the distance, we are talking this distance, right, is equal to the total distance traveled between from here to here and minus the distance traveled from here to here. Okay, so we'll basically take the difference of these two, correct? We'll take the difference of these two. Yeah, so this is equal to Sn plus 1 second, as we said, this is equal to half of the half of a square minus n square. Okay, this is equal to half a n square plus 1 plus 2n minus n square. This is equal to half of a 2n plus 1. Okay, so what is given in the problem? We basically need to find the ratio of Sn by n plus 1. Okay, so Sn by n plus 1 is basically the ratio of these two, correct? So Sn upon Sn n plus 1 is equal to half of a 2n minus 1 to half of a 2n plus 1, right? So this is equal to 2n minus 1 upon 2n plus 1. So this will be the ratio, folks. Okay. So if you look at the answer, this answer is given here. Okay. Now let's go to the next problem. A particle has initial velocity of 3. Now, the way I'll explain this one is that I'm not sure how many of you are conversant vectors. So this is a vector. So all this while we have been studying that a body is moving in a specific direction, right? So imagine we say that, okay, a body is moving horizontally, for example, correct? We are saying this, right? So, or we are saying that body is moving vertically. But what happens if body is moving in this direction, right? And we do not have a common, we do not have a number attached to it. And this is, if a number is given, this is scalar, right? But this is given in terms of vectors, right? So how do you resolve this problem? So in this case, what is given to us is that it has an initial velocity of 3i plus 4j. So what does 3i plus 4j mean? So this is 3i. In the x direction is 3i. And the y direction is 4j. Okay, so the magnitude of this is 4 and the magnitude of this is 3. You can visualize like this, right? If you know coordinate geometry, visualize like this here, correct? Okay, so this is 3 in the x direction and this is 4 in the y direction. Okay, so this is what it means here. So it means 3 in the x direction and 4 in the y direction. How much acceleration? It is 0.4 I plus 0.3 j. So it means 0.4 in the x direction. So acceleration in this direction is 0.4. Okay, and acceleration in the y direction, acceleration is equal to 0.3. Okay, so we need to find out that what is the speed after 10 seconds. Okay, so now what we'll do is that we'll find out that after 10 seconds what will be the speed in each of these directions, right? So what will be the speed in the y direction, what will be the speed in the x direction, sorry, and what will be the speed in y direction after 10 seconds. Okay, so let's talk about the x direction now, right? X direction. Okay, what is the initial speed? Initial speed is equal to 3i, right? Or 3, you say, right? And acceleration is equal to 0.4. Okay, so we know that, and time taken is 10 in both the cases, right? So what will be the final velocity then? V is equal to u plus at, right? U plus at. This is equal to u is 3 plus acceleration is 0.4 into 10 seconds. So this becomes 7. So this is speed in the x direction. Okay. Similarly, let's compute the y direction speed. Okay. So y direction speed will be similarly v is equal to now what is the initial direction in the y direction? We know it is 4j, right? It is 4. And what is the acceleration in the y direction is 0.3. Okay, so 0.3 into 10 seconds, correct? This is also 7, right? So now what does it mean here? So it means in the x direction also I have 7 and in the y direction also I have 7, correct? Right? So now what will be the, so we need to find that what will be the resultant of this, right? So basically you can imagine that both are right angled triangles. The base is 7 and the perpendicular is also 7, and this is 90 degrees, right? This is the x-axis and this is the y-axis. So we need to find out how much will be this. So this is very simple, right? So hypotenuse of a right angled triangle is equal to root of x square plus root of y square, correct? So this is the root of 7 square plus 7 square. This is equal to 7 root of 2. Okay, so this will be the answer, right? So the answer here is C. Alright, let's go to the next problem now. The displacement time graph of two moving particles make angles of 30 degrees here, 30 and 45 degrees with the x-axis, okay? So there are two particles given here. One particle is this one, for example, and the other particle is this one, okay? So imagine that this is B and this is A, okay? And 45 degrees with the x-axis. So what is the ratio of the respective velocity? So now, before we even come to this, right? So let's understand whether we know how do we calculate the displacement and velocity from the graphs, okay? So now let's take a simple problem, right? Let's take a very simple situation. Imagine that that a body is moving, right? Imagine a body is moving, so the velocity is like this. So this is a velocity and the time graph. Okay, imagine the velocity is like this. Initial velocity was this one. Okay, this is like this. Then it moves up, it moves down, it moves again further down, and eventually it comes to rest somewhere here. Okay, so let's talk about so there are 4 different time span, right? Okay, so this is one time span, this is 2 time span, 3rd time span, and this is the 4th time span. So how do you compute the distance in such cases, right? So the distance in such cases will simply be the area under this graph, right? So basically the area under this graph, this will be the distance, right? Because you know distance is equal to the speed into time. So in this case, the distance is equal to the speed into time. So this is basically the area what is there in the graph. So that will be the distance computed by this, right? Now let's go a step further. Okay, so now this was the velocity time graph, right? Now imagine if you are getting, imagine if you're getting a distance time graph. Imagine if you're getting a distance time graph. Okay. Now in this case, the distance is equal to speed into time. So there is basically this area, right? If you know rectangle also, it is length into breadth. Okay. So we basically need to find the area here, and we got it, right? But what do we do in distance into time, right? So distance into time, imagine it's like this, right? Imagine the body is traveling like this. Okay. So in this case, how do you find? So imagine that, let's take an example, okay? So imagine the body travels a distance of say 20 meters, okay, in say 5 seconds, correct? Imagine it goes a distance 20 meters in 5 seconds, right? So what will be the speed in this case? We all know speed is equal to distance by time. This is 20 by 5 is equal to 4. Okay. Now let's visualize it differently, right? Correct. So what does a tan do? Imagine there is a triangle here. Imagine there is a triangle here and this is theta. Correct. Imagine if this is 20 and this is 5. Okay. So what is tan theta equal to here? Tan theta is also equal to 20 by 5. Now, if you compare this graph, this one with this one, don't they look alike here? So it means tan theta also gives us the velocity. Imagine if this is the distance and this is the time. So basically tan theta also gave me the velocity here, right? Correct. So now going the same analogy here, so we'll come back to this one now. So tan theta, so if you know the tan theta, we'll be able to get to the velocity, right? So in this case, imagine there are two bodies here. So the velocity of this one, if I need to find the velocity of this one, is tan 30, correct? And if you want to know the velocity of this one, this is tan 45, right? Because this is 45 here. Okay, so this is tan 45 for this body, and for this body is tan 30, correct? So for the two bodies, tan theta will be the velocities. So we need to basically find the ratio of this thing, right? So it means tan of 30 degrees, because one of the angle is 30 degrees, other is 45 degrees, right? So all of us know tan 30 is 1 by root 3, right? And tan 45 is 1. So this is equal to 1 by root 3. Okay. So the 1 by root 3. So the answer is, okay. So I hope you understand this. Please let us know if you have any feedback. So these are all the problems we have for this exercise. Okay. Thank you.